Hi everyone, this is a video that accompanies my Graphs worksheet section 10. In this video you're going to learn two things. Firstly, how to solve quadratic and simultaneous equations using an alternative method to the algebraic method. That is, you're going to use the graphical method. Secondly, you're also going to gain a visual idea of what it means to solve quadratic equations and what it means to find simultaneous solutions. The worksheet and answer sheet in this video can be found on my Instagram page. A link to this is given in the description box. I also post other bits and bobs on that Instagram page, such as things about my career and my artwork. So if you're interested in that, then go check it out. Anyway, let's get into the video. Okay, in the Algebra section 7a and 7b worksheets, I showed you how to solve quadratic equations. This involves taking the quadratic equation and factorising it. If you're not comfortable with doing this, then I've linked the two videos that teach you this below. Now, we can solve quadratic equations another way. It's not the best method as it's susceptible to inaccuracy. Factorising, i.e. the algebra method, is the best method. However, it's important to know this other method because it gives you a deeper understanding of what it means to solve quadratic equations. I think it also gives you a visual understanding of solving certain equations, and also you need to know it because it could crop up on the exam. So let's just go over the method that you should already know. In this example, we're asked to solve this quadratic here. So here is the quadratic, and here is that quadratic when it has been factorised. And finally, here is the step where we find what the solutions to the quadratic equation are. So we have x is equal to -4 and x is equal to 1. These are the solutions. By solutions, I mean that the only values of x that satisfy this equation are -4 and 1. So you can check this. If you substitute all the values of x here with -4, this left-hand side reduces to 0. And so the original equation would read 0 equals 0, which makes sense. The same is true for x is equal to 1. If we substitute all values of x with 1, this side reduces to 0. So again, we get 0, 0. If we went wrong somewhere and thought that a solution was x is equal to 0, well then we can see we've made a mistake by substituting this value of x back into this quadratic. So if we replaced all these x's with 0, this side would reduce to +4. And so our equation would read 4 is equal to 0, which doesn't make sense. So we know we've gone wrong. So that's what it means when we say these x's here are solutions to this quadratic. Okay, the other method, the graph method. This quadratic equation is just a special case of this function here. If we take this function and decide to set this y here equal to 0, then we get back to our original quadratic equation. So what we can do is we can actually use this function here in place of this quadratic if we want. We can use it for whatever means, and when we finally want to get back to our quadratic, all we do is set this y here equal to 0. Yeah, setting this y equals to 0 means we have a 0 here, which means this is exactly the same as this. So that's the first step in this method, using this quadratic function in place of this quadratic equation. Now if we take this function and plot it, then we get this graph below. I showed you how to plot graphs in a number of previous worksheets, so go check that out if you don't understand how I did these boxes or got to this graph here. Okay, looking at this graph, it shows us what this function here looks like when it is plotted, i.e. it gives us a visual representation of what y value we get for any x value that we plug in to this function. Now this axis here is the x-axis, and along this x-axis is where y is equal to 0. So all the way along here y is equal to 0 because it passes through the y is equal to 0 line, if you get me. So where our function, i.e. this graph, crosses this x-axis is where this y in our function must be 0. And as we can see, this graph crosses the x-axis at x is -4 and x is 1. So for this function, when x is -4, y is 0, and when x is 1, y is 0. Right, good to know, but how does this help us solve the original quadratic? Well, remember, when this y here is 0, we're actually dealing with this quadratic. And we've just seen from our graph that y is only 0 if x is -4 or 1. So these must be the solutions to the original quadratic. And that's how you solve quadratic equations using a graphical method. You take the quadratic and plot its corresponding function on a graph. You then see where that graph crosses the x-axis. At the point that it crosses the x-axis is the point at which y is equal to 0. If y is equal to 0, then the function is actually the same as the original quadratic equation. So the point at which the graph crosses the x-axis is the solution to the quadratic. Now, just as a quick reminder, some graphs will cross the x-axis twice, in which case you get two solutions. Some graphs will maybe just touch the x-axis, in which case you only get one solution. And finally, some graphs won't cross the x-axis at all, and this means there are no solutions to the quadratic equation. Like, think Mean Girls style, there's no solution. The solution doesn't exist. If we weren't dealing with quadratics, we could also have certain graphs that cross the x-axis infinitely many times. Think of a sine wave, cosine wave. Okay, let's move on to simultaneous equations. As with quadratics, we can also solve simultaneous equations using a graphical method. Again, this isn't the preferred method or the most accurate, but it's important to learn it as it may come up in your exam. It's also good to learn it because, as I've said and I keep going on about, it gives you a visual understanding of what it means to find simultaneous solutions to certain functions. And I always found that having a visual understanding, i.e. being able to picture something in maths, really helped me. So I've gone over how to algebraically solve simultaneous equations in a previous algebra worksheet and video, but I'll quickly just go over it now. So this is the example: solve these equations simultaneously. So the first thing I like to do is to label my two equations. I then either go down two method paths. I either eliminate or I substitute. So here I've rearranged equation 1 and substituted it into equation 2. I've then reduced equation 2 to find two x solutions. X is 0 and x is 3. I then take these x solutions and substitute them into the easiest equation, which I think is equation 1, to find the corresponding y values to these x's. There we have it. These are the two simultaneous solutions that the question was asking us to find. These two xy pairs are solutions to both of the original equations. This is the key thing. Simultaneous equations are just equations that have common solutions. If that's still hard to grasp, then I think this alternative method of solving them might help it sink in a bit better. So the first step in solving simultaneous equations through a graphical method is to plot both functions on a graph. The first equation is that of a straight line, and it looks like this when plotted, just down here. So this straight line. The second equation is that of a circle, and it looks like this when plotted. So this circle in yellow. Now remember, simultaneous equations have common solutions. Also remember, solutions to functions are the coordinates that they pass through when plotted on a graph. Therefore, simultaneous solutions are coordinates that both functions pass through when plotted on a graph. Looking at this graph here, both functions pass through 2 points, i.e. they cross. They cross here, so they pass through this coordinate, and they cross here, so both functions pass through this coordinate. So what are those coordinates? This one is coordinate 3, 4, and this coordinate is 0, -5. This means that x equals 3 and y equals 4 is a solution to both of our equations. It also means that x equal to 0 and y equal to -5 is also a solution to both equations. Therefore, these xy pairs here are simultaneous solutions. And look, they're the same as what we got through the algebraic method. And that's how you solve simultaneous equations through a graphical method. You plot both equations on a graph and find the coordinates where they cross. The x and y values of the coordinates are the xy solutions to both the equations, and so they are the simultaneous solutions that you're trying to find. Again, just to point out, some equations may cross infinitely many times, so they have infinitely many simultaneous solutions. Think of how the sine and cosine waves cross each other. Some equations don't cross at all, so think parallel lines. These don't have any simultaneous solutions, i.e. the solutions don't exist. Again, Mean Girls style. Okay, right, I've put some questions together for you to try out and test your knowledge on this subject here. Like I said, the answers to these and the workings can be found on my Instagram page along with the image of this worksheet, so do go check that out if you want to see these. All right, thanks for watching.